Tomorrow morning at about 7:10, a space station is predicted to cross almost directly in front of the sun from my backyard. The entire transit will last just under 2.5 seconds, and I'm going to try to capture it with the DWARF 3 Smart Telescope. DWARF Lab has provided this DWARF 3 to me as a loaner. If you want to learn more about this telescope, it's in the description below. I actually started looking because I wanted to capture a solar transit of the ISS. Transitfinder.com showed me one, but its ideal path was an hour south of me, and the opposite direction of where I work, so it would have been a bit of a drive. We'll save the ISS for another day. What I did find was the Tiangong Chinese space station. Tomorrow morning, its predicted transit path is almost directly over my house. Let's break down what Transit Finder shows us. The predicted center of transit is less than a second away from 7:10 a.m. tomorrow morning. CSS angular size means how big the Chinese space station should appear in the sky. In this case, only 3.4 arc seconds. That's less than 1/1000th of a degree. So I'm not expecting a detailed picture of the station. If I catch it, it may only appear as a tiny dark silhouette moving across the sun. The reason why it's going to appear so small is because the distance is 1,097 kilometers, so about 680 miles. This is straight line distance from me to the space station, not the height above Earth's surface directly. The angular separation is only 0.2 arc minutes. That tells us how close the space station's path should come to the center of the sun. Like I said, I'm almost dead center in this transit. The azimuth is 80.7 degrees. Since 90 degrees is straight east, this means I need a clear line of sight just north of east. The altitude being 16.4 degrees above the horizon, that means we've got to make sure that we clear trees and walls. And since we know the sun moves about 15 degrees an hour through our sky, we can assume this is just over an hour after sunrise. The center line distance is how far I am from the center of the transit line. At 0.08 kilometers, that's less than 300 feet. The complete visible path, this 14 kilometers, is how wide this transit area is. And the farther you are on the edge of this line, the more towards the edge of the sun that transit will appear. With all this information, we can predict that the transit duration is 2.44 seconds, and the chord length is 31.6 arc minutes. That's the apparent distance Tiangong should travel while it's silhouetted against the sun. Because that is almost the sun's full apparent width, it should cross very close to the middle. So on paper, this is about as good of a location as anyone could ask for. But satellite predictions can change. And since it's 6:16 Wednesday, August 5th, and the transit's happening tomorrow morning, we're going to check it again about an hour before this transit is supposed to happen. So it's just after 6 in the morning, and we're about an hour away from the transit. So I hop back onto transitfinder.com to find the most up-to-date prediction. Last night, the prediction was almost the same in terms of time. It changed by about half a second. The center line has moved. As you can see now, the center line is 1.9 kilometers north of me, about 1.2 miles. But I'm still well within the transit zone, and if you look at these two side-by-side pictures, you can see the predicted difference of where it was going to pass versus where it's now going to pass through the sun. This is why it's really important to check the transition predictions an hour to 2 hours before you actually go and try to make the observation. This isn't the most ideal Tiangong transit for resolving the station itself. The sun is only about 16.5 degrees above the horizon, so the station will be about 1,000 kilometers away from me. That's more than twice as far as it normally is for an overhead observation, making the apparent size much smaller. I could travel a mile north to get an updated center line, but with this observation, it's kind of not worth it. But come Sunday, it looks like I'm going to have a really good transit of the ISS. So since my yard is still within the visible path of prediction, we're just going to go film it from the yard. So setting up the DWARF 3 is the easiest part. I have it on the tripod, it's EQ mounted. Make sure that you put the solar filter on before you even attempt to aim this at the sun. But we've got heavy clouds, so let's see how this goes. So it's pretty easy to set up. You just open the DWARF Labs app, hit connect, find your scope, it'll connect. And then head into live view. We're going to turn this sideways to make it better looking. You see the wide angle view in the top left, so what we're going to do is move the camera pretty much to aim right at the sun. As you can see, those clouds are a little bit of an issue here. And then in the top right, click on the mode you want. We want solar system and we want sun. It's going to say attach the filter, which we should have already done before aiming it at the sun. and then hit track, and it's going to do a panning thing to make sure that it knows where the sun is. Now, because of those clouds, autofocus might give us a little bit of an issue. So what I'm going to do is manually focus this. And then because we want to make sure we want to get as many frames as possible, we're going to go video. Now, because the Tiangong is going to be so small, we want to put the telephoto into 1x view so that we can film this thing in 4K. And we've got 30 frames per second, which is going to be great because this thing is going to take about 2.5 seconds to cross the sun. Now, with parameters, I pretty much left everything on auto. And with focusing, we can try autofocus, and it looks like it did pretty good. If it doesn't, because we have the clouds, we can always manually adjust it. The prediction for this transit is pretty much right at 7:10 in the morning. So what I'm going to do is start recording at about 7:06 and let this thing go until about 7:12, and then scrub through footage, which is not going to be the most fun, but will guarantee I get it then. So a way I like to test things too is come into Stellarium, click on this and type in whatever you're trying to track, the ISS or the Tiangong, and there it is right now. So it's going to come up over the sky and then down through the sun. So we can use this to see really when we should start recording and stop recording. But we've got about 10 minutes. And we're still tracking the sun, and it's focused correctly. It is just turned 7:08, so let's hit record. While that was recording, I just opened Stellarium and tracked Tiangong to see when it passes the sun so I know when I can stop the recording. When I saw the transit happen on Stellarium, I pretty much just counted to 60 before stopping the DWARF 3 from recording so that I had a decent timestamp to back up 1 minute to find where the transit happened. At first I was excited because whatever crossed this frame was extremely easy to see. But when I watched it again, I realized there was a problem. It's not flying in a straight line. I did spend way too long trying to figure out what this swerving object was while fighting the urge to call it the Tiangong simply because the timing seemed so perfect. But the movement didn't make sense. I've gotten a video of the ISS passing the sun before with a different tool, so I knew what I should expect. I slowed this footage down to about 10% and started watching everything to see where I could find this transit. That's when I noticed the smallest, faintest little dot moving across the sun. I've messed with the contrast and brightness here. That tiny little dot is the Tiangong. We already knew it was going to be extremely small from my location. I mean, its predicted angular size was 3.41 arc seconds. And come to find out in the morning, the observing conditions didn't help either. I had clouds passing through and a dust storm rolled through last night, leaving the sky extremely hazy. It's not exactly ideal when you're trying to capture something this small from more than 600 miles away. But with these changes to the contrast, highlights, and shadows, we can see Tiangong a little more clearly as it moves across the sun. It may not be the sharpest space station transit ever captured, but considering its size, distance, and the conditions of the sky, I'm pretty happy that we caught it at all. Come Sunday, we're going to try again with the International Space Station. The Tiangong appeared only 3.4 arc seconds wide during its transit. The ISS is predicted to appear 46.4 arc seconds wide during its transit. That means the ISS should be 13 times larger, giving us a much better chance of capturing a clear silhouette, assuming the weather cooperates. And the ISS is about twice as wide as Tiangong, and substantially more massive because of the solar panels and a couple extra capsules. For now, though, we successfully caught Tiangong crossing the sun. And the DWARF 3 made this setup extremely easy. I placed it on a tripod, installed the solar filter, used the app to aim it at the sun, and said, track and record. The station may have been barely visible, but it was exactly where and when the prediction said it should be. Now let's see what the DWARF 3 can do with a much larger ISS on Sunday.